Hello, everyone, and welcome to today's Introduction to Machine Learning with Databricks webinar. My name is Alastair Jones, and I'm a US-based data and analytics consultant with Thorogood Associates. I'm joined today by my colleague, Singh, who's also a data and analytics consultant, and will be presenting the latter portion of today's webinar. Our contact details are on the screen should you want to reach out about any of the content we discuss. Also, feel free to connect with us on LinkedIn. We do share content on kind of related relevant topics on our LinkedIns. So in terms of today's agenda, we're going to start by introducing Thorogood and providing an overview of Databricks as relevant context. We'll then discuss the basics of machine learning conceptually before delving into a hands-on Databricks demo split into two sections. So we'll start with data cleansing and then training and applying the model. We'll then share some information on MLflow, which allows you to industrialize ML solutions. And we'll conclude with some kind of next steps and parting thoughts. So we'll start with a brief introduction to Thorogood and an overview of Databricks. So Thorogood is a specialist data and analytics consultancy. We're independent, global, and customer-centric. Our consulting approach means that we seek to internalize the business objectives of any engagement, pair that with our data and analytics expertise, and deliver quality outcomes for our clients. We have offices in the UK, US, Brazil, Singapore, and India. We offer a range of services. The bulk of what we do is solution design and development. But that does inform our ability to conduct and deliver other projects, such as strategies and roadmaps, tool selections, as well as training and empowerment. So Thorogood is independent, as I mentioned, and by that we mean we maintain close partnerships with many of the key vendors in our space. A key partner for us since 2018 is Databricks. We enjoy close collaboration with Databricks across offices in various regions. So we were invited to be one of 4 consulting launch partners for Databricks as they released their SQL Analytics offering. We also presented at the 2021 Data and AI Summit, actually on the topic of machine learning and ML ops. And we're continuously collaborating on joint marketing and customer initiatives. We also have established partnerships with the major cloud vendors of Microsoft, AWS, and we're managing a Gold Microsoft partner in several relevant competencies. So there's quite a good degree of overlap between Databricks and the vendors. It's a first-party platform that sits on those clouds, and we'll get into that. At Thorogood, we deliver value in data engineering, data science, data visualization for key enterprise clients, typically within the data-rich verticals of consumer goods, pharmaceuticals, banking, and insurance. Key customers include Unilever, Johnson & Johnson, Liberty Mutual, Morgan Stanley, and many other blue chip names. So now for some more context on Databricks. Databricks comes from the creators of Apache Spark, which is an open source platform that's used for big data engineering and large analytics workloads. Databricks was founded as a private company building on Apache Spark, so building upon that foundation and enhancing it for enterprise organizations' use. They've created the Databricks service that they aptly referred to as the unified analytics platform. So the Databricks platform, I kind of alluded to this earlier, it sits on the major clouds, including Azure, so that's Microsoft Azure, Amazon Web Services, and Google Cloud Platform. It gels nicely with the other data platform offerings in those stacks and can meet the needs of both data engineering and data science use cases. It's often a component of effective cloud data architectures. As it's a cloud platform, it's very effective at auto-scaling, so only using the compute power needed at any point in time. Its notebooks can be authored in a variety of the most popular languages used by data scientists, data engineers, and analysts alike. So think of SQL, Scala, R, Python, and we'll see that during today's demo. Some of the features of Spark that have been enhanced and are available on the Databricks platform are that it can, on the data engineering side, it fits well with the native Azure, AWS, GCP storage services, cloud storage services, so ADLS, S3, the go-to kind of data lake storages. But it also now offers Delta Lake, an open source offering that allows for a bit more structure and reliability when conducting data engineering in the cloud. On the data science side of things, it comes with a lot of pre-installed packages and libraries. You also have MLflow, which is also a offering that was created by Databricks themselves, and it's open source, and it's effective kind of model tracking, and we'll touch on that towards the end of today's presentation. So now that we've kind of oriented everyone a bit to Databricks as a platform, let's discuss machine learning basics before kind of delving into how Databricks can effectively tackle some of these ML workloads. So the first thing I wanted to note about machine learning is that it's everywhere, and its presence is only increasing. So some examples you may be familiar with from your everyday life are noted on the screen. So your email spam filter, your credit cards fraud detection service may use classification algorithms to detect where an email or a transaction is likely to be unwanted or fraudulent based on relevant attributes. Netflix or e-commerce websites may use cosine similarity algorithms to recommend movies or products that would suit your tastes based on the preferences of others with similar histories and kind of likes to you. So how does machine learning work, and what are the key steps in a machine learning initiative? Well, obviously, you start with data. And as I walk through this example, I'll kind of talk about hypothetical in which we have data on people that may or may not be professional athletes. We'll have a data set containing information that includes height, weight, 100-meter speed, their credit score, their eye color, their birth month, and of course that label of whether or not they are a professional athlete. So these attributes such as height, weight, credit score, etc., they're features, and the label is whether or not they are a professional athlete. So when we look at an output or a label that is numeric, like salary, this would likely be a quantity, and we'd use something like a regression model as opposed to classification for kind of a yes/no on whether or not they're an athlete. After cleansing the data for use, we split it randomly into training data and test data sets. We can then select which features we want to use and how. So in this example, something like eye color or birth month might not have much bearing on whether someone's an athlete, but I suspect height and 100-meter speed would be correlated. We can then select an algorithm for our model, and in a moment, we'll get on to exploring how we select that algorithm for the model. In this instance, we're going to use basic clustering that groups people based roughly on the height and 100-meter speed into those athlete, non-athlete clusters. We feed our model the training data so that it can create these cluster groupings and establish the clusters of values that lean towards athlete or non-athlete. We then run our test data through the trained model to understand how accurate our model is. So we can begin to evaluate the results of the model, and we can look at how many we correctly identified as athletes, how many non-athletes we incorrectly classified as athletes, and so on and so forth. So that allows us to kind of refine our model, and we're able to iterate over time, use different features, use different algorithms as we deem appropriate until we kind of hone in on an effective machine learning model. So the iteration step is key there. And then ultimately we can feed larger data sets into our model. So then we get into the kind of MLOps side of things, scaling models over time. So I mentioned this as I was kind of talking through that hypothetical example, but how do we decide on which algorithm to use for our machine learning model? Well, we can kind of do that determination through the use of exploratory data analytics. So we can look at facets of our data that include data distribution, feature interactions, any missing values that we might have, a variable type, need for accuracy, etc. This is on the left-hand side of the slide. How do we get there? How do we kind of do this analysis? With the exploratory data analysis can be handled through a data visualization tool such as Power BI, so a BI tool, or Tableau, or you could do data summaries, and we'll touch on that actually during today's demo, and that's usually available out of the box in your ML tool, and is available, in fact, in Databricks. So we then pick an algorithm. In the world of supervised machine learning at a high level, this could be a classification predictive model or a regression predictive model. Classification uses groupings of attributes to categorize data. Regression defines a best fit line for the data so that input values can return output values in line with the other data available. It's important to evaluate models to understand how they're performing, as was evidenced in the kind of earlier diagram. So I'll now provide a kind of a high-level view of classification models. So this example is a kind of, well, what I'm sharing on the screen is a simple binary classification model with two outputs. So we can view everything in that 2x2 matrix, and it captures the kind of predictions and whether they're true positives. So for example, spam emails, which were the correctly predicted spam emails, the true negatives, the correctly predicted non-spam emails, the false negatives, so those spam emails that were classified as non-spam and made it through, the false positives, or those kind of non-spam emails that were classified as spam, so didn't make it through. So we can look at some metrics for this. They include accuracy, precision, and recall. They mean different things. So accuracy is what proportion of all predictions were correct. Precision is what proportion of the positives were truly positive. And recall is what proportion of actual positives were predicted by the model. In the example of spam emails, we may never want the spam email to make it through to people's inboxes. So recall might be more important than prediction if we're kind of weighting these different kind of measures of the model's effectiveness. Now onto the regression models. So effectively on the left-hand side of the screen here is a basic linear regression model that is fit to data. So the vertical distance between data points and the regression line is called the residual. And how we evaluate a regression model is essentially to calculate the mean squared error and R-squared coefficient. These are different measures that describe how effectively our regression model predicts values. So our model could contain bias and underfit, where the model is poorly fitted to the data, or variance and overfit, where the regression is modeled too specifically to fit the training data isn't appropriate for use on other data sets. During today's demo, we'll be looking at a regression model, in fact. So therefore, you'll hear a bit more about evaluating a regression model from Manny shortly. So without further ado, now that we've got a bit of background on Thorogood, Databricks, and machine learning basics, let's jump into Databricks. So I'm just going to navigate now across to a browser window. So this is Databricks, which is available as a web-based kind of interface. You've got that we're working with Databricks in Azure here, as indicated at the top of the screen. I can jump back to the Azure portal and see my login name at the top as well. You've got this kind of intuitive pane on the left-hand side, which allows me to jump around within kind of Databricks to different notebooks, perhaps. So there's that kind of standard pane on the left that you'd see in other cloud-based platforms. At the top, along the top of the page here, we have a kind of a menu pane. So you've got you can see which cluster you're going to be connected to. So that's essentially what cluster you're using for the compute when you're executing in Databricks. You've got a file type menu here. You can clone or create new notebooks. You've got this kind of like edit type menu here that allows you to cut, delete, etc. And you've got the option to kind of run cells in a notebook. So a notebook is comprised of various cells, sequential cells. And I'll be scrolling through some of these cells today. So each cell as well can be authored in various languages. So you can see here, this is just an initialization script. So I'm running kind of a setup notebook, but it's authored in Python. So you have the option, as I mentioned earlier, of SQL, Python, or Scala. You can alter that. You can have notebooks that contain cells with different languages used within the various cells. So what we're going to be doing today is I'm loading data from a CSV file, and it's Airbnb data. So it's data on Airbnb listings that show various attributes of a listing. One of the kind of labels that we're looking at here is price. So we were looking to predict price based on some of the features or some of the attributes that we have available. So we're just reading that in from a CSV that's available, made available actually thanks to Databricks, training amount there. So reading it in. Whenever you want to look at a data frame, so look at the output of whatever you've created. So here we're creating the raw data frame and just reading it in. You could use this display raw df or display function in Python to do that, to look at it. We're also going to take a look at the columns here. So you can see if I click within here and I scroll, you can see there's a ton of data that we're getting across the columns here. So maybe not all of that's relevant. So one of the first steps we're going to take here is to just keep certain columns. So we're going to keep the columns that we think might be relevant to our analysis today. So I've enumerated those there, and then we're kind of displaying the data frame at various steps. One thing that we may notice in our data is that we have a column that shows us the minimum stay. So we've got month-long rentals here, 1 day, 7 days. We don't want anything that was listed for greater than a year, for rent for greater than a year. That might be throwing off some of the data. So that's something that we're going to look to exclude, and we can do that via a basic filter. We also have our price. So if I scroll up here and we can take a look at the price column, we've got price that has kind of a string with a $sign involved. So what we're going to do, because we want to start using that for analysis, is we're going to actually convert that. So we're going to translate that into just a double data type. So if I scroll across here, we've used the display function again to render it, and you can see price has just standard numbers there. We spoke about data analytics and analysis to understand what's in your data before you embark on training, applying a model. So we've done a basic summary here that shows us for the different columns key information, so count, mean, min, etc. We're most interested in the price column, so we'll hone in on the view of that so you can see the key information here. We can see the 25th, 50th, 75th percentile values, the min as well, and maybe something will jump out to us there. We have listings with a price of 0. So maybe that's something that we don't want. So we only want to keep listings with a positive price. So again, we'll do a quick filter and we'll filter out everything so that we only have prices where, so we only have listings where the price is greater than 0. Handling nulls, I believe this was mentioned in the slides, but it's another important facet of considered machine learning initiatives. So what do we do with nulls? How do we handle them? There are different approaches you can take. What we're going to do here is we're going to create an additional column that just denotes where there were null values. So we're adding on the right-hand side, let's see if there's a data frame that I can scroll to. We're adding these, so bedrooms NA here, that kind of just indicates if there's anywhere where that value was a null. And then we're going to use the imputer here to essentially add or convert anything that was null into the median value for that column. So we don't have nulls, but we have the record of where nulls existed. And with that, I am going to output that file. And what I'm going to do now, and it's in that Delta format we spoke about, Delta Lake and Delta files. Now what I'm going to do is hand it over to Manny, who will talk about training and applying the model. So over to you, Manny.
Now that we're done cleaning up the data, we can move on to training a machine learning model. So the first thing that we'll do is just read in our clean data that we saved in the last section. Next, we're going to split our data into a training set and a test set. And the reason we do this is just because our machine learning model, it's going to learn on the training set. So it'll learn the patterns and trends that it needs to in order to make predictions. And then on the test set, we will evaluate the model. And the reason being is just that the test set is unseen data. So we want to know how our machine learning model will perform on that data because it's already seen the training set data, so it will perform well on that data already. So you see we'll do an 80-20% split. So 80% of data will go into training and 20% will go into testing. After that, we can establish a baseline model. And the idea with the baseline model is just to establish a benchmark for our machine learning model. And the idea, and basically we'll start with a simple model and just build up a more complex model from there. In this case, our simple model would just be taking the average price. So you can see here, we'll calculate the average price of all our listings, and we'll just predict that for every single record. You can see it's $215.27. So this is our simple model, just the mean, and we'll predict it for everything. And then the idea would be the machine learning model that we train, it would need to beat the performance of this model. And now onto performance. The way we'll evaluate the performance of this model is using the regression evaluator. And in this regression evaluator, we can specify our prediction column, which is just the average prediction that we set here. Our label column, which is just the price that we're trying to predict. And then metric name is RMSE, which in this case is root mean squared error, which is a very common metric used to evaluate machine learning models. And it's based upon that mean squared error that we touched upon during the presentation. After calculating the root mean squared error, we can see that it is 178.90. And basically, so now our machine learning model that we train next, our goal would just be to beat this root mean squared error. So now we can move on to training the actual machine learning model. And then in this case, we'll just use a simple linear regression model where we're going to try to use the number of bedrooms to predict the price. So the bedrooms are our features and the price is our label. So just displaying both those attributes here. And now here we'll just look at some summary statistics, some interesting things about, we can see the mean of both. So $215.27 looks to be about the average price for the listings, and bedrooms 1.33. If we scroll down, you can look at the min. So we can see that we have some outliers here, the minimum price being $10, bedrooms being 0, and then also on the other end of the spectrum, the maximum price being 10,000, bedrooms being 14. So these are just some outliers, and these are good to keep in mind, just in case you might want to remove them before training a machine learning model. After this, we'll try to train our linear regression model. So we'll import our linear regression model from PySpark.ml.regression, which is a popular machine learning library used for PySpark. And we'll specify our features column, which is our bedroom, since we want to use the bedrooms to predict the price, which is our label. And when trying to run this, we can see that we get an error, which is just a type error, because this library expects our features column to be of a vector type. And in our case, our bedrooms is not a vector type; it is just a numerical column. So we'll first transform that into a vector type, and we'll do that using the vector assembler library. In that vector assembler, our input column is just our bedrooms. Our output column, we'll just call it features. And then we'll use the .transform method to actually make the switch. And now, if we take a look here all the way to the right, our features column, which is our transform bedrooms column, you can see every single value is now a vector type. So now that we have done that, we can move on to training the model. So the same linear regression model that we imported, we can now train it to this vectorized training data. And now just doing an inspection of the model, this is a linear regression model, which means we can actually look at the formula for the line. So just doing that here, you can see it's y equals 123.54x plus 50.09. Now we'll apply the model to our test set in order to evaluate. And again, that will just be, we'll first have to use the vector assembler to transform the test data, again, because that bedroom column that needs to be in vector format. And then next we'll have to, we'll use a .transform method of the linear regression model to actually make the predictions. You can see our predictions here. And now when it comes to evaluating the model, you can see its root mean squared error is 149.54. So this is good for us. It's beaten the benchmark that we established above. So, and to keep in mind, this is also a very simple model by just using one feature. So there are improvements that can be made, but for now, this will do. And now that we've trained the model, we can move on to talking about productionizing a machine learning model. So we can go back to the presentation. So when it comes to productionizing the machine learning model, we run into some challenges. The first challenge that we'll see is just keeping up or just keeping track of the experiments and model development. So oftentimes data scientists are going to run hundreds, if not thousands, of different experiments. So it's going to be important to keep track of them if you ever want to run a particular experiment again. The next challenge we have is reproducibility. So you want to be able to reproduce an ML experiment because it allows you to get the same results consistently across different environments. So for example, let's say you're going from a dev environment to a production environment. You want to ensure that your model is reproducible so that it is able to integrate seamlessly into the production environment. One common challenge is a lot of times a model will work in development, but it will not be stable in production. So MLOps practices can alleviate that. Then we have comparing models. So when you run a large number of experiments, your ultimate goal is going to be to find the model configuration that gives you the best results. So you need an easy way to compare the different models. And then lastly, we have the standardization of packaging and deploying models. We want our users to be able to use our models in order to make predictions that provide value. And that's why we need a way to deploy our models to end users in a standardized way, so that we won't run into any issues when deploying the machine learning models that are created using different technologies or libraries, which is often the case in machine learning. One solution for these problems is MLflow. MLflow is an open source platform for managing the machine learning lifecycle. So it's, like we mentioned before, it is also developed by Databricks, and it comes pre-installed on the Databricks ML runtimes. And the 4 key components of MLflow are tracking, projects, models, and the model registry. But first, we'll talk about tracking, which just saves the code, configuration, results, and artifacts of an experiment. And here by artifacts, I just mean the files, like the model itself or any graphs that you may have created during model training or development. Then there are projects, which is just a format for packaging data science code, so that's reproducible and reusable. And then next we have MLflow models, which provides a standardized format for deploying machine learning models regardless of the library used to develop the model. And then lastly, the MLflow model registry. So this is a service for centralized model management, review, and sharing. And it includes aspects like model lineage, which is just the experiment and run that produced the model, and then model versioning and deployment endpoints. And now we can just take a quick look at we can go back to the demo to take a look at this. So we head down here. You can see in this code cells when we sort of use MLflow, you can see we'll import MLflow. We're on a Databricks runtime, so there's no it's already installed. We just need to import it. And the basis of an MLflow model is to use runs. So we'll do MLflow.start run and just give our run a name. In this case, just kind of describe what you're doing in this run. In this case, we have a linear regression in a single feature. And then from here, just take all the steps that you've done previously, and we can just put them in here. So so basically everything that we've done before is now in here. And the difference here, we talked about some of this stuff, but now we can log parameters. So we can use the log param method to log the label, which would be the price bedrooms. We can log the model itself, and this is really important for deployment, being able to log the model, because then you can use it later on to make predictions. So we'll log the model here, and then same, we have the evaluation, and now we can actually log our evaluation metrics. So we use root mean squared error, so we can just log that there. And now logging another artifact, we create this graph for the distribution of price, and we can actually log that as well. And after doing so, MLflow actually has a UI, so we can take a look at that. You can see this experiment tab in Databricks here, and you can see our MLflow run. And then we'll just go to the main experiment dashboard. You can see our run is right here. We can click on it. And now you can see here's the LR single feature run that we looked at before that we just created. And now we can take a look at what was logged, our parameters. We logged the label parameter, our metrics, the root mean squared error. That's also been logged. And now onto the artifacts. Our MLflow model, since we actually logged the model itself, it actually saves the model, and it gives us a way to actually deploy it. So we can see it here. It's pretty much telling us how we can use the model to make predictions, which is really nice for production. And then in addition to that, also the image is here as well, which we also log. And and since MLflow is an open source package, this UI is also available when developing locally, just spinning up a local server instead of using a cloud one. And now we're coming to an end, so we can just go back to the presentation. So I hope you found the session useful today. We have some offerings at Thorogood that may be of interest to you to continue your Databricks learning. So whether you're just getting started with your Databricks journey, or we have a Databricks workshop or a proof of concept solution to enhance your data and insights with Databricks. And if you have any other questions or are interested to learn more, please don't hesitate to reach out. This concludes the webinar. Thank you for joining.